Today is 13th of March 2025. I did data mining. First, I will introduce the concept of data mining, and after that, I will move to using pandas. So how to generate the data and how to concatenate each other and so on. First, in this data mining, we more focused on data mining. When we do data mining, there's various ways to analyze the data. I will introduce one by one. First is the statistics. In statistics, there is descriptive statistics and inference statistics. When we do descriptive statistics, there will be, in univariate case, mode, median, mean, mode used for categorical data. What is the most frequent value that come out? Variance, standard deviation, and percentile. We will see later code. In pandas, we can easily get the first quantile and second quantile by using, if you already have data frame, which let's say df, then df.quantile, and when you input the parameter, if you put 0.25, it is first quantile, and if you put 0.75, it will be third quantile. And there is skewness, which is for measure for symmetry, and kurtosis, which is measure for tailedness. There was famous book Black Swan, written by Richard Taleb, which is talked about a long tail change everything against normal distribution. We can easily see kurtosis to how the long tail has and how thick it is, so on. And based on outcome of certain random variable, if it is discrete, then discrete space, and if it's continuous, then it will be continuous space. For basic discrete model, there is Bernoulli distribution. For Bernoulli distribution, we define it as probability x equals to 1 is p, equals to 1 minus probability x equals to 0 is 1 minus q. Then we can write probability density function as p to the p power 2k multiplied by 1 minus p's power to the 1 minus k. And this is Bernoulli distribution. And if you go to the binomial distribution, binomial distribution is the number of successes in a sequence of n independent experiments. So it's kind of extension of Bernoulli distribution. And the probability mass function defined by n square divided by k square and minus k square. Except that this is the additional term behind is same with Bernoulli distribution. You can imagine the situation. By binomial Bernoulli distribution, when and where Bernoulli distribution use and where the binomial distribution is used. Bernoulli vs binomial distribution. And there's continuous distribution. In continuous distribution, there's T distribution, which is use sample data's standard deviation, except what random variable that standard normal distribution has. it's also, the statistics is also random variable. So what I do is we can do stochastic calculus and with statistics because it's random variable. And there's student t-distributions density function. It's there's gamma function and things you can observe it. And for linear regression, there's F distribution come out. F distribution is based on two different chi-square distribution, so has two different degree of freedoms. And one thing was statistics. So for bivariate or multivariate data, we can use cross tabulation on contingency tables and covariance correlation. And for each of the probability types, we have different types of functional form. And I will go to the, and I'm a bit confusing of gradient and nebula's difference, so I will figure it out. And for linear algebra, it also used a lot, especially we are using tables with NumPy and pandas, vectors and scalar multiplication. For linearity concept, in vector space, we have linearity concept. It, it, if you think like this, it can be intuitive. With scalar multiplication and vector addition, we can make straight line. So maybe it is the reason why we say there's linearity on vector space. So important concept will be linear transformation, transpose, conjugate, rank determinant, and inner outer product, metric inverse, and also there's special metrics like sparse and dense metrics, unit vectors, symmetric metrics, Hermitian and skew Hermitian, and unitary metrics. And there's a way to solve AX equals to B linear system of equation like Gaussian, Jordan elimination, and matrix factorization and decomposition. And there's basis, concept of basis, and linear transformation, span orthogonality, orthonormality, and linear least squares. And there's also decomposition method like singular value decomposition, which use eigenvalue, eigenvectors, and diagonalization concept. And my another question is, I will go to optimization and linear programming first. If objective function and constraint is linear, then it is linear programming, and there is such as simplex algorithm. And for randomization technique, there is hill climbing or simulated annealing or genetic algorithms exist. So there is, for classical machine learning algorithms, there's supervised and unsupervised learning. Supervised learning is, there's already data, we assume there's X and Y data, and we should find relationship F. My question is, when finding function F, well, should we also find the probability distribution function? Then, this is unclear. I'm still studying right now. Then, maybe we call it as functional form. And by functional form, by the probability distribution, F don't have changes, but there is changes at objective loss function because we are finding the difference between Y and YI. And if YI will have different values based on the probability distribution function. And my another question is, when you do unsupervised learning, then what is the kind of form of function F and what is the form of loss function? Form of explain the Y in unsupervised learning is totally different. So in classification and clustering, classification is supervised learning algorithm, which is predicting a category. Clustering is unsupervised algorithm, which is just make a group things to make new rows. Think of just making new rows. If the output of target variable is numerical, then it's regression. If not, then it's classification. And if you think of logistic regression, it is regression, but it is actually what people actually want to do is classification. And in validation, that it is used for hyperparameter. Hyperparameters attribute is fed by each of algorithms. And for supervised learning, there is such as clustering, dimensionality reduction, and association rule. Association rule is finding used in area such as for market searching. If to find out if customer likes item A, then he also likes the item B. They want to find such conclusion. So, because yi is different. Yeah, that's also my main question. And I will move to pandas. So how I will show you how we can generate the data. Okay. Basically, if we use, I will run it again. There's currently error at line 102, but before that, we can still see the things I've generated. So I made it as a series. So if I print it out, print as, so from 1 to 10, it printed out. And I made data frame here, which is for generate randomly. And I give index number 11, 12, 17. So if you see here, then index number, which is row number, and there's column number. So I printed out, so it generated. And this time I print DFA, which is only print A column. And next time I print AB, so they print A and B both. And for I also print for data types. So they print for each column, it's float, float, float. They give such things. And I did sorting. And if you do this, you can change it to NumPy array. That's a bit confusing. And I think I should figure it out this again. And this is you made new rows and add new column by adding two columns. And for categorical value, you can get a value of value counting, and you can do merge, inner join, outer join, left join, and right join, which is we learned during the database class. And I have difficulty on understanding this part, df.loc, and also not printing the columns, but rows, how to select rows. I will figure it out next time. Thank you very much.